Okay, so take out your pen and paper, and whatever feels important to you, you can just note that down. Okay, so we are going to start with what is limit of a function. So limit of a function uses a concept of cluster point of a set. You know, usually what we know about limit is we say limit at any point a of the function f of x is equal to some, some number L. So whenever x approaches to a, we say that f of x approaches to L. But what is the basic idea behind this limit? We are going to study in this lecture. So it uses a basic concept called cluster point of A. That means the limit point or cluster point of a set. So let's go back to what is cluster point of a set. First of all, we need to know what is a cluster point of a set. So suppose you have a set A. Suppose you have a set A and you have a point either inside this function, either inside this set or outside this set, doesn't matter. But if you can draw any neighborhood of this particular point, and that neighborhood should contain at least one point of the set, then that point will be called a cluster point. A point C will be called a cluster point if for every del there exists at least one point of that set such that that point belongs to this neighborhood C minus del to C plus del. So C could be any point inside the set or outside the set, but if you take any possible neighborhood of this C, you should always end up having some points of A inside this neighborhood. That's the basic idea of a cluster point of a set. So let's see some examples. If I want to find out the cluster points of this set, for example, 1 by 2, 1 by 3, this is a set like this. So if someone asks you if is 1 a cluster point of this set, 1 lies here, 1 by 2 lies here, 1 by 3 lies here, and so on, 1 by 4 lies here, and so on. These points keep on coming closer and closer, right? So can you draw every possible neighborhood of this point, let's say 1 or 1 by 2 or whatever? Let's check for 1 first. Can you draw in every possible neighborhood, and that possible neighborhood should contain at least one point of the set different from this point? There is a concept that says at least one point that is not equal to your point. That should be different from your point. Can you always do this? No. Suppose if I take del is equals to, let's say, 1 by 3. So when you draw the neighborhood of this point, 1 minus 1 by 3, 1 plus 1 by 3, this neighborhood has no point of the set, which is this set A. So in this case, we can say that one is not a limit point of this set. Similarly, for 1 by 2, we can also have del is equals to, let's say, 1 by 3 or 1 by 4 or whatever. So when you take the neighborhood with the radius, with the del is equals to 1 by 3, let's say, 1 by 2 minus 1 by 3, 1 by 2 plus 1 by 3, you are not going to end up getting any point other than this 1 by 2 inside this interval. So you can always have these kind of neighborhoods which make these points kind of isolated. So what is this set has any limit point? Yes, of course, this set has a limit point. We can say that 0 is a limit point of this set. Why? Because when you take the neighborhood of this 0 point, this neighborhood, whatever small del neighborhood you might have taken, 0 minus del, 0 plus del, any small neighborhood, whatever the del value can be, del could be, very small, 1 by 10 raised to power 9, whatever. But always you'll end up getting infinitely many points of this set other than 0. in this neighborhood, no matter how small your del is. I know you might have this idea in your head before, so you can relate to it, I think. So the basic idea is whatever del you choose, for that del you should end up getting infinitely many points of that set in that particular neighborhood other than, C. And why I'm saying infinitely many points, because if there exists at least one point, there are going to be infinitely many points, because in this way you can draw infinitely many small intervals, and every interval has 1 point. Even if we consider that every interval has 1 point, then we can draw infinitely many intervals like this. So we can have infinitely many points other than that particular point. So in that case, that particular point will be called cluster point. Now, 0 was not a point of this set. You might have noticed that 0 was not a point of this set, but it was a cluster point of this set, right? So yes, we can have points outside the set which are not cluster points of the set. Sorry, is anybody's mics on? Okay, maybe there was some.
Yeah, Unnati, you can continue.
Yes. So now coming back to limit point, which is a very important concept, and the most important thing I want to tell you here, which you might miss in your classes or in your normal daily routine, that it says that A is a subset of R, and you define a function A to R. This is your domain. Always the function on the left hand side is your domain. And they are saying that let C be a cluster point of C. Let C be a cluster point of this A. So the domain should have a cluster point called C. Just now we studied about cluster points. Cluster point is a point for which, for every possible neighborhood, there exists at least one point of that set different from that point. So A should have this point as a cluster point. If this condition satisfies, condition number 1, that C is a cluster point of A. If this condition satisfies, then you can go to the fact of checking that is C, then you can go to checking at this. You can check whether what is the limit of this function, right? Whatever it exists or it does not exist, okay? So first of all, you need to have that C should be a cluster point of the domain of this function. This function has a domain A, and if this set A has a cluster point called C, then you can check the limit of that function at C. Let me give you an example. Because normally questions are asked to you in a way that these are, cluster points of the set. But if someone asks you a question like this, limit extending to 2 minus x plus x minus plus under root x minus 2. So you have studied in 11th, 12th class how to find the domain of this function. So for this function, what would be the domain? This is as a whole as a function. What is the domain of this function? Because inside square root, you cannot have negatives. So you will say that the domain of this function is 2 greater than equal to x, which means the set from 2 to infinity, right? But you always also has a function which is square root of x minus 2, which is in addition with this function. So for this function, to make the square root non-negative, you need to have x greater than equal to 2. So what will you do?
Negative 2 to infinity.
Negative root 2 to infinity, yeah, sorry. X is less than equal to 2. So negative infinity to 2 closed interval. And in this case, the domain will be 2 to infinity. And of course, your function is the addition of these two functions. So you will have to satisfy the conditions for both. So in that case, you will have to take an intersection. So for this particular function, let me call this function f. So for this particular function f of x, the domain will have to be a singleton root. A singleton 2. So if someone asks you, check the limit at 2, then you need to check. This function will be defined from singleton 2 to, let's say, R. Then you need to check, is 2 a limit point of the domain of this function? This is the domain of this function, which is a singleton point. Obviously, singleton sets has no cluster point, no limit point. So 2 will not be a cluster point or limit point of this set, because if you take any neighborhood of 2, then that neighborhood will contain only one point. No matter how large that neighborhood is, that will always contain only one point, and which is the point itself. But we want a point different from that particular point. So 2 is not a cluster point of the set. So you cannot check the limit at x equal to 2. So if someone asks you this question in an interview or somewhere else, in exam you'll rarely find such kind of question. So the question in itself is wrong. Or if they are trying to ask you this question, you will say that we cannot find this limit, right? That should be your answer, because 2 is not a limit point of the domain of this particular function. Okay, so this was the concept of limit of a function, which you already have studied in your BSc and MSc maybe. But there is one thing I want to also mention about limits, that see, there is a thing called 0 less than x minus c mod of x minus c less than del. If this condition satisfies, then for every epsilon, f of x minus L, absolute value is less than epsilon, which means, this is a very important thing, x minus c less than del implies f of x minus L less than epsilon. And this will hold only if the point C is a cluster point of the domain of f of x. So if this holds, then this will hold. And this will hold for every epsilon greater than 0. If for given epsilon, if I give you a single epsilon, you can always find a del which satisfies this condition. Okay, so graphically what I can say is, if your function is something like that, let me do a little improvisation in this function, okay? If your function is something like that and it takes value, is someone messaging something? Something is important. We'll take your questions. Someone has raised their hands, I think. You can note down your questions. We'll take the questions in the end, because we have a time limit. So you can note down your questions. Okay. So let me just complete it. Even if you have question, you can just type it in the chat. So let's say this is a C point. Okay. But the function has a hole here. Function does not take this value L at C. Instead of this, function takes a value f of C. Let's call it f of C at this point. So the concept of limit says that you can still find limit approaching from, C minus del and C plus del. You're coming from here or maybe here. If you're coming from the right hand side, this will be called right hand limit. If you're coming from left hand side, this will be called left hand limit, right? And if you're doing that, this will be L minus epsilon, and this will be L plus epsilon. It doesn't matter whether the value at C is L or not. Here FC is not equal to L, but still you can find the limit, because C is a cluster point of your domain. So specifically in the limit definition, you'll always find this 0 greater than thing. That means that x is not equal to C. We are not concerned about x is equal to C. We are concerned about the neighborhoods. Okay. So when finding limits, you need to ensure that you are concerned about the neighborhoods. So this was all about the theory. If someone has doubt, I think, sir, we can take it in the end or maybe now.
Yeah, Unnati, we can consider the doubts at the end.
Okay, sir. Okay. So you
Yeah.
guys can note down your doubts in your notebook, whatever pen and paper you have. We'll take it
Unnati,
towards the end.
yeah. Unnati, if there is specific doubts regarding the problems that we are discussing, that can be entertained, but other things can be considered at the end.
Yes, sir. So if you have doubts regarding what I told you, what concepts I shared with you, you can ask. And then we'll move on to questions. We'll do a lot of questions. Do anybody has any doubt regarding the concept? Okay, then we shall move. Maybe you guys do not have any question regarding the concept. If you have any extra doubts, we'll take it towards the end. So wait for it. And let's move on to some previous year questions of JAM. In the upcoming classes, we are going to cover continuity and differentiation. In those classes, we are also going to take some questions from other exams. But now specifically for this class, I've taken questions from JAM exam because JAM has beautiful questions of limit. In each and every question, you are going to find some new concept. Okay. But this question is a very basic question. This is a 2020 question, JAM 2020. Try to read out this question. Which of the following is a false statement they're asking you? So along with that, I want to share some strategies of question solving in the exam. This is a multiple choice question, MCQ type question. And in this kind of question, only single option is correct. These kind of questions come in every exam, single correct, multiple correct. Only single option is correct. So either you find one false statement or you find three true statements, you can find your answer, right? 3 true statements will make sure that the next fourth statement is false. So you can apply different strategies if you do not have much idea about the question to solve such kind of questions which have, single options correct. So let's try and solve this question out. So first of all, for the option 1, let's try and solve it. Limit x approaching to infinity, x raised to x by e to the power x is 0. Let's check if it is 0 or not. So let's try and solve it. As you know that this is a infinity by infinity form. In the numerator, you have linear function. In the denominator, you have exponential function. Both goes to infinity as x approaches to infinity. So you know that this is an infinity by infinity form. And the most simple way to solve this kind of problem is to apply L'Hopital's rule, which is sometimes also spelled as L'Hospital, whatever way you spell it. So this rule says that you can differentiate the numerator and you can differentiate the denominator, and this limit are still going to be the same. But this is a very basic approach of solving this kind of question. We are going to do something else. And in this way, you are going to get 1 over infinity, which is going to approach to 0. So your limit will be 0 and option A is correct. Okay, we know this approach. But we want to know the answer just by looking at the question, just by looking at the option. What can we do? We have a criteria in calculus, in functions, which is called a dominance criteria for functions. What does this say? It says that you have certain functions which are dominated by some other kind of functions. For example, log n is a function, log n or log x is a function which is dominated by a linear polynomial function. And linear polynomial function is dominated by a quadratic polynomial function, and so on by cubic and so on. Sorry, I'm using n and x both at the same time. So what does this dominance means? First of all, we need to know about what does this dominance means. It says that after certain value of x, let's say our functions are defined from r to r, or maybe r plus 2r, because we want to take log x also into consideration. Log x is not defined for negative real numbers. R plus union 0, we can, r plus, sorry. So In this way, we can say that for after a certain x value, after, let's say, x is equals to 10, or let's say x is equals to 20, or let's say x is equals to 1000, you are certainly going to see a massive rise in these functions as compared to log x. So this means that log x is dominated by this kind of functions. For example, if I draw the graph of this function, log x looks something like this on the real line, but the linear function looks something like this. You always see the graph of linear function being up on the logarithmic function, and in this way you also know that the exponential function is also like this. So you know that exponential even dominates the polynomial functions also. So what is the dominance criteria? You can note it down. I'm also going to share the I'm also going to share the notebook and PDF of whatever I'm writing, so you don't need to worry much about it. Even if you miss something, just try and focus on the concept that I'm telling you. Okay. So the dominance criteria looks something like this: log x, x square, and so on, all the polynomial functions, x raised to some alpha, and then it is dominated by exponential functions, and even specifically in exponential functions, 2 raised to power x will be dominated by e raised to power x. It will be dominated by some greater value, 3 raised to power x, and so on. And then they will be dominated by n x raised to power x. So this is finally the highest dominated function. So if some function dominates the other, you know that this is going to approach to infinity. For larger values of x, this is going to go close to infinity. This is going to become very large, but this is not going to become very large. So exponential function becomes very large as compared to the linear function, because exponential function dominates linear function here. So for very large values of x, this denominator is going to approach to infinity very soon as compared to the numerator. So you can say when the numerator is finite, this becomes a very large quantity, the denominator. So something divided by very large quantity, you can use this idea. Something divided by very large quantity will go to approach to 0. And this was, if you know the dominance criteria, this is a 5 seconds question, right? B option, you can do B option by L'Hopital's rule, or you can apply, if you know that x approaches to positive 0, right? If you know that x approaches to positive 0, you can say that 1 by x approaches to infinity. Because we are coming from the right hand side towards x, that means x is somewhere here, and we are coming from the right hand side. So 1 by x approaches to infinity, right? So you can change this 1 by x, whatever 1 by x you find in this example, you can change 1 by x from, you can just substitute 1 by x by y. Okay, so if x approaches to 0, y will approach to infinity, and A option and B option will become the same, and they will give you the same answer. Okay, so A and B options are correct. If you're not able to solve B option, you can tell me towards the end. Okay, and then C option is very simple. It says limit x approaching to 0 positive, so numerator will be 0 and denominator will also be 0 by 1 plus 2 into 0, which is 0. So this will be 0. So this means the C option is also correct. Now, if you are able to find that A, B, and C options are correct, and they are asking you the first statement, obviously you can, these are correct statements, so they won't be your answer. So let me just cancel them out. So your correct answer will be D. Even at this point of time, you don't need to solve for it, but if you want to solve for it, you can just go for it. This is a very simple one. This will be cos 0, 1 divided by 1 plus 2 into 0, which will be 1. So answer will be 1 and not 0. So B statement is false. I hope this question, this easy question, is clear to all of you. So if you have any doubts, just note them down, okay? Let's move on to the next question. This is a very interesting question, but this contains some infinite products. So what to do in this kind of question? So let's try to analyze this question. Limit S is the limit n approaching to infinity. 1 minus 1 by 2 square, 1 minus 1 by 3 square, and so on, 1 minus 1 by n square, right? So what is S, they are asking you. One way you can do this question is to, how I like to do it is to see one factor of this term as a square minus b square thing. You know the formula of a square minus b square, which is a plus b into a minus b, right? So what you will do is, you can write this as 1 minus 1 by 2 into 1 plus 1 by 2. And similarly, 1 minus 1 by 3 into 1 plus 1 by 3. Why I'm doing this? Because directly it looks quite difficult to solve it. And if you're directly trying to put n tends to infinity, you are not going to get anything. So, sorry, 1 minus 1 by 3, 1 plus 1 by 3, and so on. So I am going to collect all the terms which have plus and all the terms which have minus in them. So this will become 1 minus 1 by 2, 1 minus 1 by 3, and so on, 1 minus 1 by n. And in multiplication to this, you will also have 1 plus 1 by 2, 1 plus 1 by 3, and so on, 1 plus 1 by n. Now still it doesn't seem much solvable, but what you can do is you can take LCM of these terms, and let's see what happens when we do it. So this will become 2 minus 1. This term will become 1 by 2 after taking the LCM, solving. This term will become 2 by 3. And so on. The next term, you know, will be 3 by 4. Continuing in this pattern, the next term. And the last two terms will be, last term will be n minus 1 by n. And the term before it will be n minus 2 by n minus 1, right? And similarly, you can also solve for it. And you'll see what 3 by 2, 4 by 3, and so on, n plus 1 by n. And the term before it would be n by n minus 1. Okay. Now we easily see that we can cancel out some terms, because directly putting limit n approaching to infinity was very difficult. So now let us just cancel out some terms and then we'll put n approaching to infinity. So 2 cancels out 2, 3 cancels out 3, 4, 4, n minus 1 will cancel out n minus 1, and this n minus 2 will be cancelled out by one term before it. So you will only get 1 by n from this first multiplicative term. And for the next term, we can cancel out 3, we can cancel out 4 from the next term, and continuing in the same pattern, we can also cancel out n, right? N minus 1 will also be cancelled out with the numerator of a term before it. So you will get n plus 1 by 2. This is a kind of question of observation. You should know what kind of what terms should be cancelled out with each other. So your observation skills should be good. So now this becomes a very simple question. N plus 1 over 2n. You can take n common, and I know I don't have to solve and show you. This is just simply going to be 1 by 2. So your answer becomes 1 by 2. So let me just see if, yes, we have 1 by 2 in the option. So option A will be correct. Okay, this was a very simple question. But if you know that you are not able to solve this question directly, then you can apply some manipulation for that term. Okay. Some questions are not easily solvable. Like this question. This question is very interesting. This question was asked in 2021 JAM. And the above question was also asked in 2021 exam. This question says find the limit of this integral. So the simple way would be to solve this integral. The first approach that comes into your mind is to solve this integral and then apply the limit. But this is not possible because this term is not integrable. How will you solve the integration? If you're not able to solve this integration, maybe we can bound it by some number, this integration into something. If we can bound it and we can apply limit on that, if maybe that comes out to be 0, so the bigger term is 0, smaller term would be 0, something like that. I don't know. Let's try and figure it out. But before that, what we can do is, the most basic thing we can do in this question is to apply by parts integration rule, integration by parts. See, your 12 concepts are also being used here. So they will check you from every dimension. So that's what they are trying to do. Let's try and apply by parts in this particular integral. 0 to 1 e to the power of x square into, just take this pen, into sine nx. Okay. So now question comes, which function should be taken the first function and which function should be taken as the second function? If you take this function as the first function, thinking about Eilert rule. Eilert rule is a recommendation, but this is not a compulsion, okay? This is a recommendation to solve the questions easily. But if you try to take this function as the first function, this as the second function, then you will have to integrate this function, which is impossible in the world. This is a non-integrable function. Right now, till now, it is not possible to integrate e to the power of x square. So what we will do, we are simply going to take this function as a first function so that we don't have to integrate it, okay? And this one as a second function. So I'm going to apply by parts e to the power of x square first as it is, integration of second. You know the integration of second is minus cos nx divided by the coefficient inside, that is n, minus integration of derivative of first, which is 2x e to the power of x square. I hope you remember integration by parts rule. This all we have studied in our schools. And the derivative of second again. Second, the integration of second, yes. Cos nx divided by n dx. Then again we have to integrate it. So now, this was our term. This was our term. Now we had to apply limit on this term. They were asking us the limit. Okay, limit and approaching to infinity. Can we do something and apply the limit? Yes. See, this x is independent of the limits. So this x and this, and think about this. You have to apply the limit on this cos nx by n. So when you apply limit and approaching to infinity on cos function, you know that cos function is always bounded between -1 and 1. So no matter what the value of n is, where n goes, cos will always be bounded. So some bounded value into some 0 value, because 1 by n is going to be 0 as you apply the limit. And this is e to the power of x square into some bounded value into 0 value. This is going to give you 0. This thing is going to give you 0. So ultimately you are going to get 0. But here the problem is, you have to again apply all this on a limit, all of this on an integral. So what we can do now is, can we do anything now? Should we again apply? Let's see. We are left with only one term now, limit and approaching to infinity. 0 to 1, 2x e to the power of x square minus cos of nx. Shall we again do the integration or shall we bound it by something? Let's try and do something. Let's try to bound the actual limits. So if we try to bound this limit, then this will be less than or equal to yeah. So this integration will give us 0 to 1 2x e to the power of x square. And you know that cos function is bounded by mod of cos nx is always less than equal to 1. For any domain value, this is always going to be less than equal to 1. So this thing is going to be less than equal to 1. So this will be 1 by n. Okay, dx. Right. Now, 1 by n comes outside, and inside you will get 2x e to the power of x square dx. So this is some integral we don't know about. We don't know the value of this integral, but we know that after solving this integral, you are going to get a constant value. And you have 1 by n outside this limit. So what you will get is some bounded value into 0 value. So 0 into bounded value will be ultimately 0. So what I did from the beginning was I solved this question for I applied integration by parts, and then I tried to apply the limit on the first part, and I got 0. And for the second part, what I did was I again bounded, I took the absolute value of this and I bounded this value by some another value. And I got to know that this actual, the whole value is this whole value, the mod of this whole value is less than or equal to 0. So if some mod value is less than equal to 0, you simply say that that value is actually equal to 0, right? Because mod value is always non-negative. So this implies that this integral is ultimately 0. So the answer that you will get by solving this question is 0. Okay, I hope this question is clear to you. Any of your doubts, you can just note them down. Okay, don't worry about your doubts. I'll take all your doubts. And the next problem is a little bit different. Every problem is different in itself. It teaches you something or the other. Okay, let's think about this problem. I suppose that you might have done sequence and series in your courses. It needs a little introduction of series, but let's try to solve it. Even if you don't know it, after solving this question, you will get a whole idea of how to solve such kind of question. So this is our statement, root n plus 1 minus root n. This question was asked in JAM 2022. Also very nice question. Okay, how to solve this question? First of all, you know that the summation applies on k, right? The summation does not apply on n. So what you can do is you can take this term out of this summation because this term is independent of the summation. And then for the rest of the term, we can write it as k equal to 2 to n, 1 over k into ln k whole squared. Okay. Okay. So what we can do with this kind of term is to rationalize this kind of term. After rationalizing this term, what you will get is 1 over root n plus root n plus 1. This might help us. Let's see if it does or it does not. You know what the process of rationalization is. Let me do it for you. By rationalizing, you multiply and divide by the same term so that it does not affect the actual term, but you change the sign so that you get something root n plus 1 plus root n. So after you are done with multiplying, you will get this because you are going to get 1 in the numerator. So limit n tending to infinity, summation k equal to 2 to n 1 over k ln k whole square, right? So now what we can do is think about this as a series, because limit applies on this and this too. After applying limit on these two terms, you know that this becomes an infinite series. This is an infinite series as n approaches to infinity. So you might have seen this kind of series in your coursework, or maybe not. What is special about this series is that this is a monotonically decreasing series. So this is a kind of series that looks something like this: 1 by 2 ln, my pen is not working right today, 1 by 3 ln 3 square, and so on. You know, the nth term of this series is 1 by n ln k, n ln n square. We have a rule called Leibniz rule, maybe Leibniz rule in series. I don't exactly remember the name, which says that if your nth term goes to 0, which it does, you know, if you apply n approaching to infinity, this nth term goes to 0. And this is a monotonically decreasing kind of series. Yes, this is a monotonically decreasing kind of series. An is monotonically decreasing kind of series, then this series will converge. But how will you know that this is a monotonically decreasing kind of series? Let me just give you an idea about this. So how to check if this is a monotonically decreasing series or not? So if you want to check that the nth term is monotonically decreasing or not, what you can do is to differentiate it. Do you remember? If the derivative of some function is less than 0, then that function is monotonically decreasing. So if you want to check it, you can just differentiate it. What you will get is -1 over n into log n or natural log, whatever it is, squared, and the derivative of these functions. So what will be the derivative? N as it is, 2 natural log plus natural log of n. So you have a -1 outside and all the terms inside are positive. So clearly this is a negative term. So this is a monotonically decreasing kind of series, and the nth term goes to 0. So this series is a finite sum. It gives you a finite sum. As n approaches to infinity, you realize that this is a finite sum. Finite sum means some constant value, some number you are going to get from this series. You don't know what the number is going to be, but you know that this is a finite sum. And this finite sum is being multiplied by this quantity. What is this quantity? This quantity, as you approach to infinity, will go to 0. So again, that concept came, 0 into finite sum. The concept of 0 into finite sum came. So what you will get is, the answer will be 0. So D option will be the correct option for this. So what we did in this question, to summarize, is we knew that this numerator was independent of the denominator's summation term. So we took it out of the summation. So it was like a multiplication of two terms now. We rationalized this term. After rationalizing, we got something like this. And in multiplication, we had this series. But we knew that if n approaches to infinity, this series is going to be. Also, I missed one step. What you can do is limit n approaches to infinity. You can apply on both differently. Limit n approaches to infinity, this thing, into limit n approaches to infinity, this thing. Okay. So a series which is finite multiplied by 0 value is going to give you 0 answer. So this was a question from 2022, and this was a 2-mark question, I guess. So you got 2 marks. Okay. Now let's move on to this question. Let me just zoom in. But this question is very easy. I want you all to try it at your home. If we get time, we'll solve it here. So just take screenshots from the screen, and when you're solving it as a homework, if you get any doubts, you can ask in the group. I will answer your doubts. Okay. This is a very, very easy question asked in JAM 2022. And I want you to try at home, because at the end of the day, you should not be spoon-fed, right? Should be able to do questions on your own. Okay. This is a very easy one. Okay. You try to find out the false statement. Like it is a question asked in a similar way. The first question was asked. The false statement is what you have to find out. Okay, let's move on to the next question. Let me zoom in a little bit. Oh, this is a very interesting question. This uses a concept of integration by substitution. This will use two concepts. You can see here, they have given you something. I hope my voice is audible. I hope I'm audible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you so much. So this is a very interesting question. Let me just give you an idea. So this uses two concepts. They have given you something, okay? Based on what they have given you, you are supposed to find out what they are asking, right? But what they have given you looks quite similar to what they are asking you, but it is way different than that, because what they have given you has no term in the denominator like t square, but they are asking you about t square. So what is all this? It looks something like beta gamma function. So all those who have studied, but I'll give you every possible knowledge that you need for this question. So don't worry, sit back and just focus on what I'm saying. So first concept is integration by substitution. You will need this concept by, you'll know in a short period of time. So you might be thinking, how will I know that integration by substitution will be applied or not some other technique? See, in such kind of questions, when they have given you something and that function is not integrable, whenever they give you something to integrate or to find a limit which is not integrable, either you substitute it by something or you try to apply integration by parts if there are multiple multiplicative terms. So you can try different approaches. And those who want to master the limit concept, they should try out the IIT JEE questions. They have some cool questions which are very conceptual. So try to solve the questions of IIT JEE, you will master this concept. And the second concept is of gamma function. What is a gamma function? Gamma function says that if I want to find, this is a symbol of gamma function. If you want to find out gamma of n, this is actually the integral from 0 to infinity. Infinity means that your integration has no bounds. Infinity is not actually a number. 0 to infinity means actually like this, like they have shown you in the question, limit n approaching to infinity 0 to n. This is the correct way of writing it. But when you write 0 to infinity, this actually means that your integration has no bound from the right hand side. E to the power of minus x into x raised to power n minus 1 dx. This integral is called gamma of n. So what is the significance of n here? X, whatever x raised to power is, if you add 1 to that power, that becomes the gamma of that function, gamma of that number, okay? So this becomes gamma n. Gamma function has a very important property which you might need in this question, that gamma of some n plus 1 is equals to n into gamma of n. And you can derive this property using this integral also. So this is a homework to you to derive this very important property of gamma function. So let's move on to this question. Very interesting question. Try to solve with me. Let's hop on to what they have given us. Limit n approaching to infinity. They have given 0 to n e to the minus t square dt is equals to root pi by 2. They have given you this. Even if you don't remember what the value of gamma 1 by 2 is, this particular piece of information that they have provided will help you in knowing that. So this is a non-integrable term, as you know that e to the x square or e to the minus x square are not possible to integrate directly. So what I'm going to do is to substitute t square as z. So what I'm going to get is 2t dt is equals to dz. So I can get dt is equals to 1 by 2. T means square root of z, dz. So I can substitute this in my question. So after substituting, what I'm going to get is limit n approaching to infinity. Or in simple words, as I explained you, I can write 0 to infinity for the time being to save my efforts. Okay. This means the same, e to the power of minus t square. T square is z. Okay. Dz is actually, sorry, dt is actually this. So 1 by 2 root of z dz. Okay. So this becomes 1 by 2, 0 to infinity, e to the minus z and z to the power of 1 by 2. So now we studied gamma function, and gamma function says whatever is in the power of x, just add 1 to it and you will get it. You will get the
Negative 1
gamma
by 2.
negative 1 by 2, right? So this becomes gamma of negative 1 by 2 plus 1. Is gamma only defined for integers? No. Gamma is also defined for, gamma is defined for specific quantities also. When you study gamma function, you will know more about these properties. But right here, it's not needed. So this becomes gamma of 1 by 2. So whatever they have given us is actually gamma of 1 by 2. We realized it. If you study gamma functions, you already know the value of gamma 1 by 2. But it doesn't matter if you know or you don't know, because they have provided us with decent information. So according to this, our gamma 1 by 2 is given by them to be root pi by 2. And this, there was also 1 by 2 outside. I forgot to write 1 by 2, 1 by 2, 1 by 2. So 2 cancels out 2. So gamma 1 by 2 becomes root pi. All those who have studied gamma functions might know this already, but no problem. This made us realize that this is gamma 1 by 2. Okay, this is something gamma 1 by 2. Now we are supposed to find out this quantity. Let me just write it down. Second, let me just create more space here. Okay. Now we are supposed to find out this limit. E to the minus at square minus e to the minus bt square divided by t square. So I'll solve for one and then we'll generalize it. So I'll just solve for this one. E to the minus at square 1 by t square. The purpose of me solving the above one was that we got to know about the approach of solving this kind of question, e to the power of some squared quantity. So what I'm going to do is, whatever this term is, I'm going to put it equal to some substitution. So I'm going to put it equal to at square. I'm going to put it equal to, let's say, u. Okay, 2at dt will become du then. Solve with me. Then we need to find dt. So dt becomes 1 by 2a. And t is, you know, from here t you can find out to be root u by root a. So root u by root a. Okay, that's it, du. So if you want to further solve it, you can write it as 1 by root a root u du. So this is your dt. So let me just substitute everything in this. So I'll get 0 to infinity. this will be 0 to infinity, because if you substitute 0 here, infinity here, you are going to get the same values for you. So 1 by t square became nothing. 1 by t square remains the same. The t square's value is u by a. T square is u by a. U by a. So 1 by t square is a by u. Okay. This is, and now this becomes e to the power of minus u, and multiplied by it will be dt. dt will be 1 by root 2 root a root u, and this is all, everything we need. Now, if you want to cancel out something, you can, for sure. 1 by 2, I'll take it common. A will be cancelled out with this. So in the numerator, it will be root a. And in the denominator, you will have u to the power of 1, u to the power of 1 by 2, which will be u to the power of 3 by 2, e to the power of minus. After doing so, we know that this thing becomes, 0 to infinity, e to the power of minus u, and u to the power of minus 3 by 2, right? Du. So this becomes what? Root a by 2 and into gamma of whatever the power is, just add 1 to it. Minus 3 by 2 plus 1. So root a by 2 into gamma of negative 1 by 2. Now how to deal with gamma of negative 1 by 2? See, you know the property of gamma function, that n plus 1, gamma of n plus 1 is nothing but n gamma n. So gamma of 1 by 2 is actually something minus 1. Minus 1 by 2, gamma of minus 1 by 2. So from here, you can find out gamma of negative 1 by 2. So gamma of negative 1 by 2 becomes negative 2 times gamma of 1 by 2. And gamma of 1 by 2 came out to be root pi. If you remember, it was root pi. So it is root pi minus negative root 2 pi. So this term becomes minus negative root 2 pi. So root a by 2 minus, just create more space. Okay. Wait a minute. Okay. So this was negative 2 root pi, and this is root a by 2, right? So this becomes negative root a into root pi. Nice, very nice. Okay. So this was our first term. And in this similar way, we can find out our second term. Just be careful while solving the second terms. The second term involves a b different from a. Instead of a, we have b, and instead of plus sign, we have a negative sign. So change a by b and change minus by plus sign. So you will have plus root b into root pi. So when you add them up, when you add these two terms, this is your whole solution. You don't have to solve for both of the terms differently. You can take help from one another. So this becomes root pi as common. Your answer becomes root b minus root a. This is your final answer. Does it match any of the options? Yes, it does match the option D. Okay, clear to everyone? This is root pi into root b minus root a. I hope that is clear to you. If you have any doubt, you can ask.
No.
Move on to a few more questions that we have. So we are heading towards interesting questions. Okay, let's try and solve this question. Try to use your head. What will be the solution of this kind of question? This is also a limits question, but it uses a totally different concept. You might have studied a concept called, there is a concept called integral as a limit of sum. You might have studied maybe. Let me just write it for you. Integral as a limit of sum. This concept says that if you want to find the limit of a summation, let's say the summation starts from, k equal to, let's say R1 and ends at R2, and this is of the form 1 by n into f of k by n, something like that. Then you can just solve this integral to find out the limit of this. To find out this value, just solve for this integral if it is easier to solve the integral. So what we do is we replace this thing by integral. Actually, it is not a replacement, but it is like a substitution kind of thing. But to understand and to remember things, we say that we substitute it by this. We substitute 1 by n by dx. And instead of k by n, we write it as f of x. This has a proof. If you're keen to know the proof, you can always go on Math Stack Exchange. You will find a lot of answers there, or you can follow books. Okay. So let's try and solve this. So what is alpha beta? You might be thinking, what is alpha, what is beta? Alpha and beta are the upper and lower limits. How do we find them out? We apply limit and approaching to infinity on the lower summation value divided by n. And similarly for beta, we do the upper summation value, which was the upper limit of the summation, R2 divided by n. And then we get alpha and beta. So how does this thing is going to help me in this question? Let's try and figure it out. So let me just write the first term for you. Limit n approaching to infinity, 1 raised to power 4 plus 2 raised to power 4 plus up to so on, n raised to power 4 divided by n raised to power 5. Let's try to solve this, just this term, okay? So in this term, I can write this term in the form of a summation, because without summation, I won't be able to apply this. So let me write k is equals to 1 to n and k raised to power 4. And since the summation does not apply on the denominator, I can also write this term in denominator outside it. Or maybe I can do this thing. I can also write it inside. But to modify this in the form of integral as a limit of sum, what I can do is take n as common outside. Summation will be from k equal to 1 to n, k by n raised to power of 4. So n power 4 is here, n raised to power 1 is here. So the total power of n is 5 in the denominator. Now this looks something like this. You can find some links from there and there. So yes, obviously this is f of the form f of k by n. So what we can do is now is we can write it in the form of integral and just directly solve it. This is a very easy task to do. So in the form of integral, we'll have some limits we don't know about. 1 by n will be changed to dx, and this thing will be changed to f of x, which means k by n raised to power 4 will be changed to actually x raised to power of 4, right? K by n is directly changed to x. So lower limit will be limit n approaching to infinity, the lower limit of the sum, that is 1 divided by n, which is 0. And the upper limit will be the lower limit of the the upper limit of the summation, which is n divided by n. And this is equals to obviously 1. So 0 to 1, you will have to integrate this function, which is a polynomial function. And this is the easiest thing to do in the world for you now, right now, because that is just 1 by 5. Okay. I don't think I need to explain you this concept. This is 1 by 5. Okay. So this limit is nothing but 1 by 5. But there is also one thing that's left. There's also another term, this. This can also be solved in the same manner as limit. Okay, let me just do it for you. Now you might be getting an idea about how to do it, right? Let's see. So you need to find this limit. Limit n approaching to infinity, 1 by root n, 1 by root n plus 1, and up to so on. You need to find this limit up till, let's see, up till 4n. Can I write 4n as n plus something? Yes. How can I write 4n as n plus something? What do I need to add in this? I need to add actually 3n, right? To make it a 4n. Why did I do that? Why in this world I did that? Actually, I wanted to take common root n. So when I do that, outside I'm going to get a root n. But inside, what I'm going to get is root 1 plus 1 by n. Up till now, I think you might have gotten the idea of what I'm trying to do. Okay, 1 plus 3n by n, right? Something like that. Or maybe 3 I can write. But outside it becomes 1 by n, and inside it becomes a summation kind of thing. So this becomes 1 plus 1 r by n. Can I write it as like this? And r varies from 1 to 3n. Do you agree with me? R varies from 1 to 3n. Right? 3n, this is 1. 1 plus r by n, and r varies from this place to this. I hope this is clear to you.
Yes, ma'am.
Yes, ma'am.
Okay, let me create some space. We are running out of space. I'll share the PDF with you, thinking that it would help you in the future. So how will I solve it now? Let's see. I can convert it. I can write it as dx. I can write it is in the form of f of r by n, which is actually going to be 1 over 1 plus r by n will be replaced by x. So 1 over 1 plus x. And this limit will have something, some upper limit and lower limit. So let's try and find out the lower limit, which is 1 by n, limit n approaching to infinity. And the upper limit will be limit n approaching to infinity, the upper limit by n, which is 3n by n. So this comes, sorry, 3n by n. This comes out to be 0, this comes out to be 3. So you need to integrate this within these bounds. Okay, so integrating, after integrating, as you all know that you can integrate it, you will get, I think, this. And when you put these limits, what you will get is 2 into square root of 4 minus square root of 1. So 2 into 2 minus 1, which is 1. So answer will be 2. So this was the second term that I solved for. The first term was 1 by 5. So when I add 2 and 1 by 5, my answer is going to be 2 plus 1 by 5. In decimal points, it can be said that the answer will be 2.2. So let me write the answer. This is 2.2. This was a quite easy question. This used the concept of limit as a integral as a limit of sum. But these two terms took a little time. This was a little time consuming kind of question. This was a numerical answer type question. In numerical answer types, you know that in JAM exam, you don't have any negative marking. Okay. Okay, so let's move on to the next question. I hope it is clear to you. This is a very, very easy question, and I want to give it as a homework to you. I included this question just to give it as a homework to you. Okay. You just will it. Okay.
Ma'am.
This is a very nice question. I'll give you a hint of solving this question, and after that, you will be able to solve it. This uses L'Hopital's rule. L'Hopital's rule. Okay. So over and over again, you might have to use L'Hopital rule, but at the end, you will get an answer of this question. I'll also share the answers of these questions in the group because I don't remember the answer right now. So I'll share the answers of these two homework questions. Okay, now we are left with two questions. No, this is just a single question we are left with. This is our final question. Let's try to do it. I haven't covered much questions, but I have covered much of the concepts that you might need while solving any limit question. We have done like 3 concepts, and this is a 4th concept that will be used while solving a limit question. So this concept uses a concept called differentiating an integral. Differentiating an integral. This sounds pretty weird. If you haven't studied something called Leibniz rule, this is a kind of tongue twister, Leibniz. Differentiating over an integral. So we summed over an integral, we did a lot of things, but we didn't differentiate over an integral. Now, why do we need to differentiate it over an integral? Because see, the first approach that we follow while solving this question is to just apply the limit a. So if you apply limit a approaching to 0, the lower limit is 0 here. The upper limit will become 0. This will also become 0. This is also again 0 already. So if you integrate any function from 0 to 0 limits, if you sum, integration is kind of a sum. If you sum a function from a point to itself, from the same point to the same point, you are going to get 0. So the denominator will be 0, the numerator will be 0. So this will become 0 by 0 form. And in such cases, you know that you use L'Hopital's rule. And to apply L'Hopital's rule, what you will have to do? You will have to differentiate this term, this denominator and this numerator. So to differentiate this kind of a thing, we need a rule called Leibniz. So let's see how will we use Leibniz rule. So Leibniz rule says, if you want to differentiate, if your function is given to you, and this is in the form of variable of t, and if you want to differentiate this complete integral, whose limits are in the form of x, then how can you do that? They ask you to simply substitute wherever you find t and another variable, the variable with respect to which you want to integrate the function. You just substitute that variable with the upper limit first, okay, and then derivate the upper limit with respect to x. Then again, you put a minus sign between them. Then you again substitute the t value with the lower limit itself, and then you differentiate the lower limit. And then you add the partial derivative, the integration of the partial derivative of the inside function with respect to x. So this seems quite dangerous, but let me apply in this question and you'll get an idea of how we are going to achieve it. Zero to a sine x square is something, sorry, sine x square, I suppose. This is something we have to, this is something we have to differentiate. So d by dx we want to do, so sorry, d by dx, because we want to differentiate it with respect to a. Why? Because we are taking limits on a. We are approaching a approaching to 0. So L'Hopital rule says that whatever the point on which you are applying the limit, you will have to differentiate with respect to that point. So we are applying limit on a, so we'll have to differentiate with respect to a. So obviously, you know, after solving this, even if you're not able to solve this integral, which you are clearly not, because this doesn't seem an integrable function, even if you solve it, after solving it, you will get a function of a, let's say some ga, and then you can differentiate it with respect to a, right? So that's why this Leibniz rule says that you differentiate the given function not with respect to x. You cannot differentiate it with respect to x, because ultimately it is going to be a function of the limits itself. After solving it, you will get a function of a, not x. So that's why you differentiate it with respect to it. So let's try and do it. So what we will do is, first of all, they say that wherever you find x X means X is acting as T here. You can read the formula side by side. X is acting here as T. So wherever you find T, you substitute with with X with the upper limit. So I'm gonna write it as sine of, I found X, I substitute it with the upper limit, which is A. So sine A square into the derivative of this limit with respect to A. So d by dA of this upper limit minus, wherever you find X, put the lower limit in the function. So sine of 0 square into the derivative of the 0 function with respect to A. So I have done my 2 steps, right? I've done already these 2 steps. So step 1, step 2. Now for step 3, they are saying you partially differentiate whatever the given function is with respect to X. What is X? X is the function, X is the variable of limits. So here X is equals to, X is equivalent to A. And your, yes, this X is equivalent to, sorry, this actual X is equivalent to T, and this A is equivalent to X in the above question. So now what I will do is I will add the partial derivative with respect to A of the given function, which is sine X square. Since this is a solo function of X, you know that this partial differentiation is going to be 0. So this whole term becomes 0. This whole term is also 0. Everything is 0 here. But this whole term is not 0. This becomes 1 into sine A square. So the derivative finally comes out to be, sine A square, right? Sine A square. Now for the second term, for the denominator term, if you follow the same process, you can do them by yourself. If you follow the same process in the denominator, what you are going to get is ln of A plus 1, and this is whole squared, right? So you have 2 terms now. Your problem reduces to limit A approaching to 0, sine of A square. After applying L'Hopital rule, after applying L'Hopital rule 1 time. This is what my situation is, because I have differentiated the integral ln of A plus 1 whole square. Now you apply A approaching to 0 limit. What you will get is 0 by ln of 0 plus 1, that is ln 1. ln 1 square is obviously 0, so 0 by 0 form. Again, you will have to apply L'Hopital rule second time. Let us apply. Now this becomes a very easy question for you. Sine A square has a derivative called cos A square into 2A. You're differentiating with respect to A. In the denominator, you have 2 into, because the power is going to be come down. And ln, the inside integral is 1 by A plus 1. Now try and apply the limits again. What you will get is 0 in the numerator, and in the denominator, what we will get is, again, we'll get 0, I think. What is it? 2. Yes, it is again 0 by 0 form. Because of this, you'll get 0. Because of this, you'll get 0. So let me just modify it, and I will then apply. 2 will cancel out 2. So A into A plus 1. This A plus 1 gone up. Cos A square. ln of A plus 1. I want you all to solve it with me. Now finally, oh, there is one more question. This question is a little different. Let's see. Okay. So what you will get? You'll have to apply U into V rule. So U as it is, we differentiated minus sine A square into 2A plus cos A square as it is, that a plus a square differentiated will be 2a plus 1, 2a plus 1, right? And this will be 1 by a plus 1. So if you apply limit now, this thing will become 0 and this thing will become 1. 1 over 0 plus 1. So the answer comes out to be 1. If I'm not wrong, the answer is 1. Anybody can confirm. And so the answer will be option B. Okay. So this was all. This used a really easy concept of Leibniz rule. And this is the latest JAM question of 2023. Right? This is how IITs are asking question these days. Okay. This question I have included by mistake because this used some extra concepts of sequences. So we are not going to cover this question in class, but you guys can try this question, and if you have any doubt, you can also ask me. I'm going to share all this content into the group, whatever I have taught you. Okay, this was all from me. If you have any doubts, you can ask. Sir?
Okay.
No.
Okay. Thank you, Unnati, for this nice session with a good collection of problems. You may feel free to share your comments, ask your queries. First of all, keep your video and audio in the on mode and introduce yourself first before asking the question.
Hello, sir. Hello, ma'am. My name is Sharda, and I'm from WMO College, Wayanad, Kerala. Ma'am, thank you so much for this wonderful session. And we have got many ideas about how to approach a problem from different point of views. Thank you so much. Ma'am, I have a small doubt in finding the gamma function of -3, 1 by 2. Can you explain me?
Okay.
I was trying to ask it at that time, but my microphone was not working at that time.
This is a very easy task. It will just take 1 minute. Okay, so we found out gamma of 1 by 2, right? Which was root pi. And we also have a property that we know that. Do you have any doubt regarding gamma of 1 by 2? Because this has a proof, I know, but I used this in finding using, I found out gamma of 1 by 2 using the details that they provided in the question. So I have started the problem from here. Gamma of 1 by 2 is root pi. I've explained how did we do that. We applied by substitution method. And after getting gamma of 1 by 2, we know that we have a property of gamma function, that gamma of 1 is n minus 1 into gamma of n minus 1, right? So you can also call this property as gamma of n plus 1 is n gamma n, which is similar to this. Both are same. So now we want to find out gamma of minus 1 by 2. And we know a relation between 1 by 2 and minus 1 by 2 is that minus 1 by 2 is, 1 by 2 is minus 1 by 2 plus 1, right? So what I can write is here, if I use this property, I can write, if I take n is equals to minus half, okay, then what I can do is gamma of minus half plus 1 will be equal to minus half gamma of minus half, right? And now, and now what I can do is, this thing is nothing but gamma of 1 by 2. You know that this is 1 by 2, and this is something we have to find out, gamma of minus 1 by 2. So gamma of minus 1 by 2 will be equal to what? This will go here, so minus 2 times of gamma of 1 by 2. So gamma of negative 1 by 2 becomes minus 2 times whatever gamma of 1 by 2 was, which was again root pi. So this becomes minus 2 times root pi. And you can explore more values using these properties. This was just one. When you go on in depth of these, you can explore more properties and more values. You can also find out gamma of -3/2 and something like that. I hope it is clear now. Even if you have any doubt, you can ask.
Thank you, ma'am. It's clear now.
Okay.
Thank you, ma'am, and thank you for this session. Thank you so much.
Shraddha.
Thank you, Sharada. Yes.
Hello.
Yeah.
Hello, ma'am. I am Divyendra Raut. And now I am doing my MSc in Ramakrishna Mission. Ma'am, I have a
Yes.
question that when you are solving a question regarding to limit, there was a series whose general term was 1 by k into whole square of ln k. Then I'm fine with the fact that the series is monotonically decreasing by derivative test. But you told that this series is convergent by Leibniz test. I don't get why this is convergent by Leibniz test. Because Leibniz test is applicable for alternating series. So, ma'am, tell me how this is
Okay.
convergent series.
Yes, we can apply some other test on this. You are right. Maybe I was wrong there, because it is applicable on alternating series. Yes, you're right. So we can apply, maybe there is a test called 2 raised to power n test. What was it called in series? I don't remember exactly the name, but there are many tests. Yes.
Ratio test. Something like.
We change the terms by 2 raised to power n and then multiply one term of 2 raised to power n, something like that. I don't remember the name. We can also apply that test here. And not because series I've done a long time ago.
Condensation.
Condensation. Yes,
Condensation.
exactly. Cauchy's condensation.
Yeah.
You can also apply that test here, and that decreasing kind of concept that we have monotonically decreasing term, that will also be used there. Cauchy's condensation test. So I tried it with condensation test also. It will work well. You can try it with that also. My bad. Due to
Okay, ma'am.
yes, it was my bad.
Okay. Okay, others.
Good afternoon, ma'am.
Good afternoon, Praveen.
Ma'am, I am a BSc Mathematics student, third semester.
Yes.
My doubt is like now each of the questions that you have given or discussed in the class follows different approaches. So is there any systematic way we can go about this?
You can solve a lot of problems on limits. That's the only way you can go about this. And there are many books on limits, because limits, continuity, differentiability is a topic of IIT JEE too, and they ask really hard and good level questions. So that is one way you can practice through their books, but you don't have to go that much deep. You just solve previous year questions of IIT JEE, IIT JAM, NBHM or GATE. That will be enough for that. And you can find extra problems in the internet also. So I won't say there is a systematic way, but yeah, there are 4 to 5 different approaches that you can apply that we use today to solve limit questions. Mainly these cover 90% of the questions, and the rest you'll have to practice.
Okay, ma'am. Thank you.
Okay, thank you, Praveen. Others? Okay, please, if it's possible, please keep your video. Yeah, that's good. Dharmendra, yes, you can continue.
Good afternoon, sir, and good afternoon, ma'am. The session was very nice and program also very enjoyable, and some concept are new also. So it's like in one question, integration changed to matlab limit changed to integration. This type question was very good. Kindly, can you suggest which book you used? You are telling some core concept.
Okay. For the most of these questions used very basic concepts of 11th, 12th class. And I just collected the previous year problems for solving these, and try to solve this question on my own, and then I just prepared the lecture. But you can always follow the basic books. As I said, this is also a concept of IIT JEE, so you can also follow kind of books related to IIT JEE also, because they ask good questions in IIT JAM too, but this is not a very kind of a topic which is very much looked into, because we often ignore limits. We are not that much into limits, but I have observed during the past few years, like 2 or 3 years, they have started asking some good level limit questions. So you should practice these questions, and mainly the concept, you can do it from any book. You are asking about book, the concept of limit, you can do it from any book, but the main thing is about practice. So you practice and lots of questions which you can find anywhere. Okay, this is a very famous topic.
Yeah, Dharmendra, you may, for instance, you may use Thomas calculus or Pan calculus for getting a good collection of problems, exercise questions.
And also, if you want to clear your concepts, Bartley is a good book for real analysis. I always trust that book. I love the
IIT JEM, question come from directly beta gamma function.
Sorry, I could not understand what you asked.
मतलब alpha beta, beta gamma function are directly asked in IIT JEM or not?
Actually, they are not directly asked, but they asked in this exam. So that's why they gave you some overview of, they gave you some previous information, and based on that information, you had to solve it. So it also used a little property of gamma function, but more specifically, they are not in the syllabus. They are in the syllabus of GATE exam, but not in the syllabus of JAM exam. So whenever they are giving you these kind of questions, they will give you some hints. They'll provide you with some hints, or maybe some other approach can also be used for solving this question. Maybe I haven't thought that way. Maybe you guys can figure out without using gamma function. If someone of you comes up with some new approach, that's very well. Because usually whatever that is not in the syllabus, they are not supposed to ask it, and they don't do it generally.
Like this, they can ask also Laplace, which can use more time in integration also.
Maybe, but not the whole concept of Laplace they will ask. Even if they ask, they will ask maybe one question in the future exams we can expect, but we cannot rely on that one question. You understand, right?
Okay.
Even if they ask,
Yeah,
we do not care much about that one question out of 60 questions, right? So we should focus mainly on the syllabus, what they are providing.
Yeah. Thank you, man. Thank you, sir.
Okay, thank you, Dharmendra. Others?
Ma'am, I have a query about regarding to classes. Ma'am, will classes be held every day in that time? Or
See, we will share the information regarding the classes in our WhatsApp group as well as in the Telegram group. You can collect the information from there. Okay.
okay, sir. Thank you.
Okay, others?
I'm not in a WhatsApp group. Please, how to add the WhatsApp group?
So please share the link of the WhatsApp group in the chat.